Okay. Good morning, Ohana. And my name is Rahul Malhotra, and I'm going to give you a session on decoding locker service. So a little bit more about myself. I'm a software engineer at Salesforce, and I'm a blogger and YouTuber at SFDC Stop. You can reach out to me anytime on my Twitter handle, that is @RahulCoder. And if you want to know about latest in Salesforce, so you can give a try to my blog. Today's agenda. So we are going to know about introduction to locker service, then why Salesforce introduced locker service. The third thing is how things are affected by locker service. And the final thing is disabling locker service. So before moving ahead, I want to tell you a short story about Steve. So Steve is working as a Salesforce consultant at a good company like you and me. But Steve doesn't know about locker service. So for any problem in Lightning components, like any kind of JavaScript, you can say library or anything else, what Steve used to do, he used to take up the board and show to the clients that it's all because of locker service. So one day, Steve made a decision to learn locker service. So he got to know that locker service is a powerful security architecture for Lightning components. But the question is still there that why Salesforce introduced locker service? What was the need of that? Why Salesforce come up with locker service, right? So as the legendary Steve Jobs have said, that customers don't measure you how hard you tried, but they measure you on what you deliver. So the product that you are delivering should be good. So the Mark Benioff, the CEO of Salesforce, has also said in the DF18 keynote that trust is the #1 value that Salesforce focuses upon. So to prevent security, we need to provide our clients secure applications in which they can trust and on which they can have a faith upon. So the next part is why Salesforce introduced locker service. Salesforce introduced locker service for a number of reasons. The first point is cross-site scripting. So locker service enables to prevent cross-site scripting and other security issues. Cross-site scripting is basically when you have a malicious JavaScript code that can be embedded into your web application. So you can say that I can embed a JavaScript code into my text field, and I can save a record. So every time my record is loaded, that JavaScript code will be executed. So that kind of functionality should not be there. So that's why Salesforce introduced locker service to prevent the JavaScript code. The second point is to prevent the components from having unrestricted access to other components' rendered data. Suppose I download an application from the App Exchange, and that consists of a calendar. So that application should not have access to many opportunities data or other data that is displayed in the Salesforce. So this is the second reason. The third reason is to prevent components from calling undocumented or private APIs. Private APIs are basically some methods in my library that consist of, you can say, that are not documented properly or that are not available. So to prevent from calling undocumented or private APIs that are, you can say, that are not active right now, locker service take care of that for you. The final point is to enhance the security of JavaScript code by following the best practices. So locker service allows you to use best practices only while you are writing your JavaScript code. So if you are using any other practice that is of harm to the security, locker service will take care of that for you. So the next point is how things are affected by locker service. Locker service enables JavaScript ES5 strict mode. So this is basically what we were talking about, that locker service consists of some best practices of JavaScript. So this is how it enables the best practices of JavaScript that we have to follow while we are making or building Lightning components. Next point is while locker service is enabled, a Lightning component can only access the data rendered by other Lightning component that is in the same namespace. So suppose you have two Lightning components. One is a different namespace, and the other component is in different namespace. So they have access to each other's data only if they belong to the same namespace. However, if they belong to different namespaces, they cannot access each other's rendered data. Like I gave you example about the calendar application previously, so that is the example of same. The third point is that locker service provides secure wrappers for all the global objects like window, document, etc. So in JavaScript, we have a number of global objects like window, document, we have event, we have $A if you have used Aura. So Locker service provide you secure wrappers of all the global objects. And what these secure wrappers actually contain, they contain some limited functions as well as some functions that are hidden from these secure wrappers, because Salesforce focuses on security and wants you to use the functions that are secure enough to use. The next point is Salesforce Classic and Visual Force-based communities are not affected by locker service. So this is one more big reason for you to move to Lightning, because Salesforce Classic doesn't contain locker service. It doesn't have that much of security implemented. The last point is, if a Lightning component is used in Visual Force, it is affected by locker service. So if you are using Lightning out or any kind of other application to use a Lightning component in your Visual Force page, then it is affected by locker service. So it's time to code. Let's move on to our demo and see what locker service has. So what I have done here, I have made a simple Lightning application that consists of some text like button 1 and 1 to 3. And then I have a text box here and I have a button here. So let's move on to the code. I have my application here. And I'm extending force:/SLDS so that I can use Lightning Design System in my application. And then I'm calling the locker service demo comp1 component directly from here. If I move on to my component, it has an Aura handler which has a name in it and value is this. So what this basically do, when my component automatically loads, it automatically calls the doInit function that is defined in the controller. So we'll now move on to our controller and see what this doInit function is doing. So this doInit function consists of a number of console logs for window. Like you can see, I have done here document.toString, component.toString. So what you are trying to figure out here, that while locker service provides me the actual variables, the actual global variables, or the secure global variables. So I'm just rendering it to string to check what I have here. So I have used window, I have used document, and I have used $A, I have used event. All these are the global, you can say, constants of JavaScript. So when we move on to the console log, we can see here that for window, we have secure window available. For document, we have secure document. For component, we have secure component. For Aura, $A, we have secure Aura here. And for our event, we have secure Aura event. So we can see that whenever we are using these kind of constants in JavaScript, like window, document, or event, we are actually using the secure wrappers, and this is taken care by locker service itself. Moving ahead. So behind Aura handler, I have made a Lightning card with title button 1. And so this is button 1. And inside that, I have made a paragraph with value 1, 2, 3. So the div has an ID of my div 1 and Aura ID of my div. I have given it two IDs. First is ID and second is Aura ID. ID is my div 1 and Aura ID is my div. Below that, I have a paragraph showing 1, 2, 3. I have a Lightning input with Aura ID is my input. And I have Lightning button with Aura ID is button 1. And the name is also button 1. And what I'm doing on onClick, I'm clicking the button and I'm calling the controller function click button 1. So the Aura ID's name is button 1 only. And click button 1 is called when this button is clicked. So let's click this button and see what is happening on clicking this button. So I have 1, 2, 3 displayed here. And I will go to my click button 1, and I see some console logs here too. So when I click this button, some of the statements will be printed. So let's clear our console. And right here, suppose, hello, Dreamforce. And I'm going to click this button now. So you can see here that the button and all the stuff is finished away. And I have hello, Dreamforce written over here. And I have console log some set of statements that are shown here. So let's move on to our code again and see what are the statements that I was showing here. So the statements, first of all, it consists of document.getElement by ID. And I'm getting the div using the ID of the div. So if I move on to my div, it has an ID of my div 1. So I'm getting that div, and I'm showing the inner HTML of that div. And below that, I'm console logging getting my div. Simply a statement getting my div. So this is a paragraph that I have shown. So if you remember, in our div, I have a paragraph. The second thing, I had a Lightning input. And the third thing, I have a Lightning button. But when I displayed here the inner HTML of div, I have a paragraph only. So what can I figure out from this is that when I display the inner HTML, it is not able to access the Lightning input, as well as it is not able to access the Lightning button, because Lightning input and Lightning button are both in the different namespace, whereas my paragraph is in the namespace of my component. So locker service don't allow you to use other things that are in the different namespace. If I see the code here, I can see that input and button are in the Lightning namespace, whereas my paragraph is in my component only. So that is why when I display the inner HTML, it consists of only the paragraph and not the Lightning input or Lightning button. So what I'm going to do now, I'm going to use a second approach to access that div only and display the inner HTML again. So now I'm using the aura ID of the div, that is my div1, and I'm going to display that. So what I have used here, I have used component.find my div.get element, because now I'm using the aura ID of the div, that is my div, and I have console logged my div into string so that I can see what I have, and then I'm console logging showing elements inside my div. So if you can see here, for div I have a secure element, and it is also written over here HTML div element. So when I'm accessing the div, Locker service provide me a secure element of that div. So I'm not accessing the actual DOM, I'm accessing the secure element of that. And then I have a statement written over here showing elements inside my div, in which I will again show the inner HTML because I have accessed it using Aura. So I'm console logging my div.innerHTML now. So I have again the same paragraph. So using these two approaches, first of all, we use document.getElement by ID. And the second thing we used is component.find. I access the same thing using two different approaches. But what I can figure out is that on both the cases, I'm just getting the secure wrappers of that div or that element, right? So Locker service provides me the secure wrappers of that. So the same thing I'm doing with the buttons now. So I'm going to get a button because it has an aura ID of button1 using component.find. So if I go to my component, my Lightning button has an aura ID of button1, and I'm going to get it and store it in a variable named as button1 only. So this is button1. And then I'm console logging getting button1. And finally, I'm displaying the name of the button. That is also button1, and I'm also displaying the button1 to string. So if you can see here, I'm displaying the button1 to string, and I'm displaying the name of the button1. That is the value that is in the name attribute of button1 to string. So I have displayed the button1 to string and also displayed the name attribute of button1. So I can see in my console log that getting button1 is here. So now I'm getting the secure component reference here. So what this means is that button is in different namespace, that is in Lightning namespace. So I'm not getting the actual secure element. I'm getting a reference to that secure element, right? So a reference to that secure component is available when I'm accessing button1 because it is in different namespace. So it has some kind of limited functionality that I can use only. And below that, I have displayed the name of button1 using simply component.find button1.getv.name that I have did. And then I'm using a different approach to get this button1 again, and that is by event. So when you are clicking button1, what you are doing, you are calling this function. And this function has three attributes: component, event, and helper. So the event attribute will consist of a reference to this button1 only. So what I'm doing, I'm getting the source of the event, that is a reference to that button, and I'm again displaying the same things again. That is, I'm displaying the button1 in string, I'm displaying the name attribute of that button1, and finally I'm displaying the other stuff that we'll talk about. Okay, so I got that button using event.getSource, and I'm displaying the button1 to string, and I'm displaying the name. So here we can also see that I am getting the component, secure component reference, and I am getting the name of button1, that is button1. So we again tried two different approaches. First, by using component.find, and second, by using event.getSource to get a reference to that button only. And in both the cases, we only get the secure component reference to that button1. So I can figure it out that if I use even different approaches, I am going to get the secure wrapper of that only by the Locker service. So below that, OK, so this is button1 and getting button1 by event. And Then I'm displaying a simple console log. This is button 1 by event. And then I'm doing the console log in which I'm displaying the variable button 1 by event that I got from here. And then I'm console logging this is button 1, in which I'm displaying the button 1 only. So in case of this is button 1 by event, I have a variable which I have displayed here. So it consists of a set of functions that are allowed by locker service for us to use, because locker service limits the functionality in terms of the functions that are available. So locker service allowed us to use these kind of functions only when I'm accessing the button from a different reference. So if I go to this is button 1, then also I'm getting the same set of functions that I got earlier. So if I use any kind of approach, I'm going to get the same set of functions only. So what I got now, I got the input value from my, you can say, input text field. Because when I click the button, the input text field value I got, and that got, the whole div was replaced by that input value. So I'm console logging that. So this is my input field with aura ID, my input. I have accessed my input field using component.find and then the aura ID. And then I have got the value of that input field. So below that, I have displayed the value. And I am using document.getElement by ID, my div1. And I'm setting the inner HTML of my div1 to the input value. So using this, all the data that was inside my div finished off, and it got replaced by my input value. So as you can see in the result, if I move to here, that in the result, I have hello Dreamforce displayed here. And also in the input value, I have console logged that. So it is displaying hello Dreamforce. And just have a look at this undefined too, because we are going to talk about it now. This is the last statement of the code. So just a minute. OK. So I have console logged the input value. Hello Dreamforce was there. And this thing was undefined. So why this was undefined, I have written over here my div.child element count. So this is one of the example of private APIs, or you can say unrestricted APIs in Salesforce that locker service prevents. Because suppose in a single div, you can have different components from different namespaces, right? So child element count is not going to give you the correct result, because it is giving you, that is why Salesforce has prevented that, and it is giving you undefined. Because the other components are not accessible, so it is only displaying the paragraph. So it will give you one which is not correct. In actual, 3 elements are there in the div. OK. So now I have to show you one more thing. So we talked about the best practices in JavaScript, right? We talked about ES6 that is implemented by locker service. So there is a small demo on that too. What I have used here, I have used a script tag to show some JavaScript simply. And I have created a variable named test. Let me remove that. And I'm console logging 2 statements. And finally, I'm evaluating a JavaScript here that consists of alert, hello, awesome admins, and developers. So when I execute that code, I'm getting ABC, and I'm getting 5 here. And I'm getting hello, awesome admins, and developers. So this is the ABC which was displayed. Then I use the evaluate function to evaluate that sum that is here. So I got 5. And then I got the alert, hello, awesome admins and developers, right? So what locker service actually do, it removes this. And when I refresh this page, I'm getting an error that test is not defined. So it allows you, it actually enforces you to use the best practices. Like if I'm declaring a variable, then I should use the var keyword. So locker service use that. So if I use the var keyword, then again my text is defined. One more thing is that locker service don't allow you to use the eval, because eval function is can execute JavaScript. So suppose I'm adding some code here, or suppose I'm getting my data from the external API, and I'm putting that in the evaluate function to sum anything. So if I get any kind of malicious code, it will be executed too. So this is another example like eval that cannot be used in Salesforce if we are talking about Lightning. Moving back to our presentation, disabling locker service. So you can disable locker service for a component by setting the API version to 39.0 or lower. Locker service is disabled for any component created before summer 17 and unsupported for browsers like IE 11. So don't mix the component API versions. Take care of the same. Suppose you are using a child component and parent component. So don't mix the component API versions. Suppose you have for one locker service enabled and for one locker service disabled. So one will be using secure wrappers, whereas other will be using the actual DOM wrappers. So that will not work. So now Steve knows about locker service and is able to meet the customer expectations, and so do you. You can get the code and references to my GitHub repository or SFTC stop blog and presentation. You can take a picture of the same. To deep dive into locker service, you can use the Salesforce developer documentation and locker service API. And you can move on to Trailhead also, because locker service has a Trailhead too. OK, any questions? OK, then. Thank you.